sala mesmo?
Eu não sei, peraí, deixa eu ver aqui. 12:30? Aí você volta pro network. Essa sala, eu acho que é essa sala mesmo aqui. Acho que essa sala vai ser só usada agora por causa do painel, porque não tem sala suficiente. Mas
Tá,
aí depois você volta para ela no network.
tá
Vou
certo.
até já copiar esse acesso aqui também, para não
Oi,
ter
pessoal,
BO.
bom dia.
Bom dia.
Estou aqui para moderar não, né? Enfim, ser o monitor de uma das sessões das 10. Eu estou no link
Uhum.
certo, será?
Tá.
Certíssimo, Rafael.
Beleza.
Ó, já estamos transmitindo no YouTube. Rafael, já vou passar o host para você também.
Legal.
Host. Bem, é
Sou o
isso.
host.
Perfeito. Bem, já está
Beleza.
transmitindo no YouTube, eu vou mandar o link lá no grupo.
Legal.
Beleza.
E aí agora, Jefferson, só para confirmar, eu só preciso então gravar, né?
Isso, aí a hora que começar o painel, aí você bota para gravar também.
Tá bom, pode deixar. Legal.
Valeu, obrigadão. Até mais, Rafael. Até
Valeu.
mais, cara.
Tchau, até mais.
Valeu. Cara, e você vai ficar aqui nessa sessão também?
Não, daqui a pouco eu já estou saindo, só estou disparando aqui um e-mail pro pessoal, para os participantes,
Tá.
porque eu tenho que estar aqui 12:30
Uhum.
para a última sessão de networking.
Uhum, tá bom. Não, pode deixar que aqui tá garantido, então.
Então tá, eu vou fechar aqui, que eu vou fazer o envio dos e-mails agora,
Tá bom.
e qualquer coisa, estamos aqui.
Tá bom, obrigado.
Nada, tchau.
Hello, Rafael.
Olá. Hello.
Hello. Morning.
Good morning.
We were in another room.
Yeah.
Some problem. Yeah.
Were there any other participant of the event, or just
Yeah.
you,
They
the
are
panelists?
coming. Yeah.
Oh, okay.
Professor José Gregorio is already connected.
Hi, Rafael. Sorry, is that
Good morning.
we received a different room, so we were all talking in the room, and then we noticed that the conversation was very nice, but we were paid to be in a conference. So then you sent your message. Okay, so here we are. It is Professor Coiti is here, Professor Gregorio is here, Professor Khalil is coming, and I see Vitor Hugo, a good friend, Vitor Hugo Monge, very good friend, and Rafael Crispin, who is going to help us. So let's, Khalil is entering. So, okay, so okay. So now formally, good morning. Can you begin, Rafael? Tell me when you can begin. Okay. So good morning, everybody. I am Ari Plonsky, the scientific coordinator of the Center for Technology Policy and Management of University of São Paulo. And I have the pleasure to coordinate the session in the Triple Helix Conference, which has a very challenging name, Theranostics, and has to do with an opportunity that appeared, which is a call from the National Council for Scientific and Technological Development, this NPQ, to establish a master's and doctoral degree in innovation, which should be very transdisciplinary. So to make a long story short, last year, the university, some of the university graduate courses organized themselves. We submitted a bid to this call under the auspices of the Provost for Graduate Studies, and the focus of this proposal, the acronym was SPRINT, but the focus was theranostics and bioprocesses. So our session now will have, let's say, these two eyes. On one aspect, we have the subject theranostics and bioprocesses, but from the other eye, we should see it as a theme, a challenge for graduate students and for cooperation with industry, and this is part of that call, to develop a stronger focus of the university in innovation already during graduate studies. So it's a pleasure being with Professor Coiti Araki, Professor José Gregorio, and Professor Khalil Khaim. And thank you, Rafael Crispin, with a doctoral student in innovation management, for helping us. We will follow this order. First, we'll have the three presentations, and then we'll have the floor open. I'll begin with Professor Coiti Araki. Professor Coiti Araki is a senior, very senior researcher, professor in this area from the Institute of Chemistry of our university in the São Paulo campus. He is A1 researchers from the CNPq, from the National Council for Scientific and Technological Development, and he is the coordinator of this project. His field is theranostics, and I would say that because of the passion, not only the knowledge, but the passion that he has for theranostics, several university graduate courses united along this subject. So Professor Coiti, thank you for being with us. The screen is yours.
Thank you very much, Professor Polonsky, for the kind of introduction. So I will, sorry, here. Good morning, everybody. Thank you very much for joining this session. I will try to explain the motivations of this Sprint USP program that is driven by theranostics and bioprocesses. This is a program that we just started that is intended to be a germ of a new organization model and modus operandi for design and development of projects in graduate student project based in open innovation strategies. And this is also for us opportunity to create new partnerships and strengthen USP connections with spin-offs and companies. And improve while training students and promoting the development of technologies and innovation. So we would like to improve the degree of maturity of our technologies, giving them real perspectives to generate products and process for the market. And also, this program should be, how to say, challenging enough to be a program of the university. So we choose something that is based on multi and transdisciplinary project at the frontier of knowledge. So we choose theranostics and bioprocess as our to drive us. So this project involves many areas like chemistry and biochemistry, materials and nanomaterials, biomedical science, biotechnology, bioinformatics, big data, all possibilities that when joined together will give the possibility of really improve and mature these ideas to have something that have real chances to go to the market. This is articulated. Those are the areas that should be articulated to get such a result. So we joined Institute of Chemistry, Biology, Polytechnic School, Medicine, IPT, that is the Institute of Technological Research, and many others. At least, actually, we have about 30 institutes that were joined together with the Institute of International Relations, the Knowledge City, and the Institute Butantan in various campuses, exactly with this intention. So when we talk about our two subjects, theranostics and bioprocess, I will focus on theranostics, and Professor José Gregorio will focus on the bioprocess area. So theranostic agents are advanced nanomaterials for simultaneous diagnostic and treatment of diseases by personalized molecular therapy. So this is an idea that is already put forward more or less 10 years or some ago, but there are still many scientific and technological challenges that must be overcome. So this starts from the conception and design of the materials and the production, testing. All subjects are still open and on discussion. So we believe that the achievement the advancement on this field will raise the level of Brazilian science and technology to a new level, a new standard of competitiveness. So this is our goal with this project at the University of São Paulo. And when we talk about theranostics and which kind of materials can be used to achieve such a goals, the nanoparticles are one of them. So we are talking about engineered nanoparticles in which we have a core material that is coated with different kind of functionalities that give actually the properties that are needed for this material to be used in diagnostics and treatment of diseases. So it is very important to control both the core and also the surface chemistry in order to achieve that. And one of the requirements is having very small nanoparticles with narrow size distribution that has high colloidal stability. This means they should be kept as they are when injected in the body. So this is something that is not is not so easy, because small changes in the surface chemistry, for example, can lead to agglomeration. And our body, in our blood, for example, we have a cocktail of different kind of chemicals and biological biomolecules that make this process quite difficult. For example, if you look at this movie, we have two nanofluids that have similar properties. As you can see, you can, for example, pass through a 0.2 micron filter with no problem. They looks like the same, but actually they have a difference. The material that is on your left remains as isolated nanoparticles interacting strongly with the solvent, so generating a magnetic fluid. While in the right case, we have agglomeration process, and we have, for example, separation. The agglomeration is not interesting because it can clog, for example, vein and arteries. Okay, and not only that, those materials should be avoid the immune response because then they will be trapped by the cells, for example, by endocytosis, pinocytosis, or phagocytosis, and also we should try to avoid the excretion organs like liver, like the kidneys, to increase the time these nanoparticles remain circulating in the blood. And in this context, size and composition, the agglomeration state, morphology, the surface chemistry, the surface charge, all contributed to control those processes. Also, there is another interesting phenomena that can happen when those materials goes into the blood. As I told you before, we have a lot of different kind of biomolecules that can interact directly with those nanoparticles, covering they up and generating actually what is called a corona that can change completely the properties of those nanoparticles. So how to control those characteristics is one of the subjects of our studies. Of course, how they interact, how with the biosystems in vitro and especially in vivo is another point of great relevance to achieve real materials with a chance for real application. So we are studying, for example, how the change in the surface chemistry, the surface charge influence, for example, the uptake of those materials by cells. And as shown here, is not, for example, just the charge of the particles that is relevant. Generally, negatively charged particles is considered less prone to be to interact with cells and be incorporated by them. But as shown here, this is not true. Actually, we can have negatively charged particles that can be uptaken efficiently by cells, depending on where those negatively charges are localized. For example, if those charges are localized on the interface of the nanoparticle and this molecular layer, this interaction seems to be very effective with the cell membrane. On the other hand, when those charges are localized just at the outermost part of the nanoparticle, this interaction, this electrostatic interaction with cell membrane promote decrease actually the uptake. So small changes like that in the surface chemistry and the morphology can change the interaction of the nanoparticles with the cells and also with tissues and organs. And this means also will change the corona effect. So when we talk about theranostics, we must choose which kind of diagnostic method we are going to use. There are many of them, but we are focusing essentially on MRI and also radio nuclides imaging. And this is the techniques that we choose for the diagnostic process. And first of all, we must generate a platform that is can be used to make the diagnostic, and also that is can be used to add other functionalities, for example, the drugs for the treatment of the diseases. So what we did first was the development of iron oxide nanoparticles that are dispersed in water, and that when injected, that can be injected in vivo without causing any problem. And that gives a nice contrast, as you can see here. And after 1 day, it starts to be cleared, and you can recover the initial image. And this sensibility of this material is quite good. But the main point here is that we started to understand how to overcome and how to generate a stealth material against the to cope with the immune system, and also that can be cleared and in order to have no cause no harm to the body. And but this has some nice properties like very high relaxivities. This means high contrast sensitivity, but we have a problem here because this material respond only to one of the one of the relaxation mechanism that is available for MRI. That is T2, but T1 is quite weak. And this problem must be solved. In this context, we try to develop something new, a new ideas to, to incorporate a delivery system and also this diagnosis system in order to get smart nano biomachines that are able to target some T cells and tissues, and also delivering pharmaceuticals for the treatment, but also have these diagnostic tools that can be used to localize them and say, oh, we have some disease or other disease. So this can be done by changing the structure of this kind of particles like micelle, liposome, nanocapsules, and nanospheres, and adding different kind of therapeutic agents, radiopharmaceuticals, for example, drugs, PDT drugs for your hyperthermia and so on. Inside, we can put, for example, outside those iron oxide-based nanoparticle MRI contrast agents, and also to target properly the diseased organs and tissues. It's possible to use biomolecules like antibodies, aptamers, peptides, lipids, and so on. And those are, of course, used for targeting agents for molecular therapy in order to have an early diagnostics of the diseases. So this is possible, and we have the spiral, Dr. Khalil here to describe what has been done. Spiral is a partner together with the USP in this project, and he will describe in more detail the state of the art. And so the Sprint project, Sprint USP project is a theranostic and bioprocess driven project for training of graduate students. And for that, we are dealing with globally relevant health and production issues. We are multi and transdisciplinary area. Also, those subjects are scientific and technologically challenging, and we believe are motivating and suitable for training of those graduate students. So this is a description of what we are done here at the University of São Paulo, and we would like to thank you all for the kind attention.
Thank you, Professor Koichi Araki, for the inspiring presentation. As I mentioned, not only knowledge, but also passion, and in advancing the frontier of science, and also doing it with an eye of how to overcome the famous valley that separates science from benefiting society. Thank you so much. Now we'll have, if I understand, Professor José Gregorio. Professor José Gregorio is from the Institute of Biomedical Sciences of University of São Paulo. He is also the coordinator of an interinstitutional program, graduate program in biotechnology, which brings together several schools at the University of São Paulo, and also two institutes that were already mentioned by Professor Koichi Araki, IPT, which is Institute for Technological Research, the largest industrial research institute in Latin America, and the Butantan Institute, who is now becoming famous because It is one of the developers and producers of COVID-19 vaccines. Both are very close to the university campus, really, I would say, part of the same ecosystem. And Professor José Gregorio coordinates this graduate program in institutional graduate program in biotechnology. And his specialty is bioprocesses, and so he will follow on the presentation of Professor Guijaraki. Professor Gregorius, thank you for being with us.
Professor Gregorio, you are on mute.
Now, I am not mute now. Okay. Thank you so much for your kind presentation, Professor Aripronsky. And I think you are seeing my screen. It's okay?
Yes.
Yes. Okay. Let's just put it on full screen. As Professor Ari and Professor Koiti told for us, I will talk about bioprocess. And the first question is, what are bioprocess? Bioprocess were developed even before the 19th century with process to produce vinegar, wine, and ethanol. This process were developed even before the 19th century. But in the 20th century, it was sophisticated, and the main component of bioprocess, the bioreactors, were developed greatly and allowing the culture of not only bacteria and yeasts that were the main macroorganisms used in bioprocess, but also to cultivate plant and animal cells. Bioprocess today is much more sophisticated. When you talk about bioprocess, we are talking of the ancient process for production of different compounds, including antibodies or ethanol or wine or something like that. But we are also talking of microfluidic systems to produce different and sophisticated compounds. And considering the development of recombinant DNA technology, even a plant or an animal can be considered as a bioreactor to produce different compounds of human interest. If you go to the supermarket, probably we will be able to know that we are using in all days. Everybody is using in products derived from bioprocess, like glutamic acid or lysine or xylitol, or even enzymes in laundry are products from bioprocess. In the agriculture, we have also bioproducts like inoculants used to improve the growth and reduce the use of fertilizers. And if you go also to drugstore, you will know that we are using products currently in every day, almost in every day. Vaccines are products from bioprocess. So the COVID vaccines are produced in bioprocess. But one of the most important process in Brazil, or in larger scale bioprocess, is the production of ethanol that you use as a fuel. The sugar and ethanol mills are are in the concept of biorefineries producing from sugarcane, sugar, ethanol, and even electricity. It's a great example of success of bioprocess in large scale in Brazil. But there are others in the agriculture, the production of biogas or the production of biodiesel or even jet fuel is also products derived from bioprocess. Bioplastics, biosurfactants are also products from bioprocess. This slide, I stole some pictures from Dr. Koichi, Professor Koichi, that Professor Koichi used about the theranostic. This I try to put together bioprocess and the theranostics. As Professor Koichi showed for us, the theranostic is based on nanocapsules, nanospheres, or nanoparticles. And these nanoparticles can be improved by different components. For example, antibodies can be produced from bioprocess. Different drugs to be released in these systems could be produced by bioprocess. The DNA, RNA fragments could be produced in bioprocess. Enzymes could be produced in this bioprocess. And even the matrix, the core of the nanoparticles could be based on products from bioprocess, like biopolymers that are produced directly in the bioprocess, or even molecules that are produced and then polymerized and used for as a matrix of these particles. Biosurfactants are other components that can be used for this process. One interesting example of a biopolymer produced from molecules is the polyethylene. Polyethylene is produced, for example, in Brazil by Braskem, and this is a product derived from petrochemical industry. But it's possible also to produce ethylene from ethanol, and then it's possible to produce polyethylene from ethanol. So it's possible to develop a sustainable production of polyethylene. So the term "I am green" is in this sense. Here, Braskem is exploring commercially this trade name "I am green" to say, oh, yes, I have a polymer which is more sustainable. When you think in agriculture, we have many interests in the main topics of theranostics, release and targeting. And it could be used to develop an agriculture, a more sustainable agriculture, using particles to release different fertilizer or substance to control plagues and so on in agriculture. And to finish my presentation, I just like to highlight the main objective of a graduate program: to train human resource to work with excellence in society. And to finish, especially with this specific program of CNPq about the master and doctoral academic programs in innovation, I will use not exactly the words, word by word, that Professor Ari Plon say when we are starting to discuss this project. But I hope I can get the idea. But since Professor Ari Plonsky is here, he can correct me if I make one mistake when I translate the idea here. The most important aspect of the MyDai program is not the financial resource provided by the company to carry out the project. Values are of little relevance. It's real. The most important is that the companies the company's commitment to participate together with the universities in the training of human resource of quality. I hope I have properly translated the idea, Professor Eric Plonsky. Thank you for your attention.
Thank you, Professor José Gregorio. Not only you translated it properly, you improved the idea. So it's very important what you said. And just to give some background, CNPq provides grants for students, for graduate students, both master, doctoral, and also undergraduate students as a kind of a part of the package. But a part of the cost of these grants should be covered by companies that are interested in this particular project, and in cooperation with university, and in also having obviously an interest in, as Professor José Gregorio said, high standard young fellows. And this is what was meant. The companies are providing a modest part of the resources, but this is a commitment. It's not only sending a letter, how nice what you're doing, we're interested, but any company, small, large, or medium, before spending money, will take decision, will discuss among the board. And so the idea of cooperating with university at this particular point, developing new human talent, is very important for us, and it's a learning process. So therefore, we thought this is not a conference, Triple Helix, about chemistry, advanced chemistry, or about biotechnology or bioprocesses. But it's a conference about Triple Helix and innovation. So this is a wonderful case where we have the Triple Helix in action in a modern way. We have CNPq, which started, jump-started the process by having this call. We have the university, which has an experience in graduate courses and in doing advanced research. We have the companies, some of them were mentioned by Professor José Gregorio and by Professor Koichi-Araki, that have interest. So the idea is to make all of us work together and learning. Not everything will go smoothly, but the important thing is that we are doing it and we shall learn from that. Thank you again, Professor José Gregorio. And now I have the pleasure of inviting Professor Khalil Khaim to join us. He has a double position, one with one foot and one hemisphere in his brain. He is at the university, at the School of Medicine, and with the other foot and the other hemisphere of his brain, he is in a startup called Spyron that Professor Koichi already alluded to. And at the university, he works with very advanced 7 Tesla technology for imaging, which is used also for autopsies, an advanced way of doing autopsies. And he will bring us his take on what we are presenting today to the members of the Triple Helix community. Professor Khalil, thank you for being with us.
Thank you very much. Thank you for the invitation too. I will share my screen. And I'm a medical physics. I'm working with magnetic resonance, and we are developing the results from the university nanoparticles produced recently. Is a strong collaboration, and the Sparrow is in the market now. Development as a new nanoparticles with different characters is very important for us. And just to understand what I talk about, magnetic resonance image correspond to 5.6 billions in the whole world. This is the market size. When you perform an exam in the magnetic resonance, almost 25% needs a contrast agent. In other words, you need to inject something in the patients to get these results in screen. This is very important for diagnosis. The number of the doses per year is around 30 millions. And when you think about this, 4 top players regulate these markets. It's very concentrated in these companies. And to show the markets for the MRI contrast, we have around 30% of the department of the GERB is only the revenue for the GERB is around 1/3% of the revenue is only for the MRI contrast agents. But all agents available for the patients is gadolinium based, and gadolinium has toxicity for us. Of course, that when you inject the gadolinium, these evidence lesions, the way very important for the radiologist, but you have problems. If this gadolinium is staying in your body, you have problems like nephrogenic systemic fibrosis. These conditions can create this disease. This is specific when you have free gadolinium in your body, and because this you need eliminate. And patients with renal insufficiency has this problem, and the risk for these patients is increased. 90% of the people in the world has this condition. In Brazil, this represents 70 million of the people that are contraindicated to receive the gadolinium. Another point about this is about the gadolinium retention. This happens if you don't have renal insufficiency. The problem here is if you need more than 1 dose when you follow your treatment. And the gadolinium stay in your body forever. After this injection, 5 years after, 8 years after, you can see the high intensity in some parts of your body. This condition has created around the gadolinium contraindications and some problems that the radiologist in the clinics always have to think about the risk and benefits. This is complicated, and the contraindicates extend for the pregnant, the pediatric patients, and other conditions. Because the alternative for this, the community are looking for the alternatives a long time. It's not new for us. What is new and what Spiral has is a solution that's more safe. This is the point. It's not the application specifically, but the safety is the point. This is our solution versus the gadolinium. You can see that you can get good results. You don't lost information for the reports, and this is in the real time. This is what you are developing. We have the MVP for this, and the histological results show after 24 hours or 14 days that you don't have tissue damage. This is very important. And the main point here is because our solution has a renal excretion. another similar solutions stay in your body, because the elimination is about the metabolic pathway. And this is not one problem for this. This high intensity that you are seeing in screen maintains along around the months in your body. Our solution not 24 hours after, you don't have more this high intensity. We have elimination of the nanoparticles of your body. This is very important for us. And you can see, you can show more details for some structures in the body. Well, until here, you can see that you have a solution, an alternative for the gadolinium. You can substitute with the gadolinium. It's complicated to think about that, but these are real alternatives that you can put in the market. Because this, we need and believe that you can do more. For this, we're investing in people like professors in this conference. This is the main engagement for us in this new approach using our solution. This is link the nanoparticles with the target agents. In October, we submit the sprint USP together with the Chemical Institute. In February, Spiral was approved, and May, the project linked the nanoparticles with aptamers specifically to check the concentration of our nanoparticles in lung and prostate cancer is our goal. We are put this together, of course, thinking theranostics. This is a great picture. You can see many technologies for each point of this picture, but who do that? This is the point. The people, the professionals, the students that needs to create conditions and expertise for linking our solution with the antibodies, aptamers, and other conditions that guide our products and take a good results. And when you do that with our solution, we are thinking a product more safe and accessible for all. Because when you think in this technology, it's easy to think in money, in high values, and one or two centers in Brazil that you can do that. And what you are proposed here is a conjugate this to get this available for all in all states. If you have MRI equipment, you can use. This is the point. But you need people that need to do that. And this is the idea to invest in the sprint USP. This is my message for you, and thank you very much for all.
Thank you, Professor Khalil. You gave a wonderful example of this triple helix in movement, and it's also wonderful because we are not talking about incumbents that have already a lot of experience in a field which of cooperation, which sometimes is, I would say, a little bit more than troubleshooting of a problem in a company. We are really talking about number one, advancement in science. Number two, a startup with a big idea. The idea, as was mentioned at the end, of being able to escalate. It means wherever you have an MRI equipment, you should be able to do it with less harm to the patient. And finally, all this jump-started with a not large amount, relative terms, a very modest amount by the federal government. So triple helix movement, excellent example. We began a few minutes later because for some reason we received earlier a different room. So it took us some time to realize that you were awaiting us in a different room. So please be with us for 10 minutes more. And so we'll have time for one or two questions. And I would like to invite Dr. Victor Hugo Monge to pose the first question. Dr. Victor Hugo Monge is a very senior practitioner, head of R&D of a multinational chemical company in Brazil, and also with strong connections to the university, and now helping as a consultant one of the largest sugar and cane alcohol corporations in Brazil, trying to make this connection happen. And Victor Hugo, please, you have the floor to pose a question.
So instead of writing, I think it's better to talk. I will
Yes,
show
yes,
my
yes,
face.
yes.
We are in a small group, and the idea. So I love to see different tech.
Hello, your sound. Victor?
Energy.
Victor, we lost we lost you for a minute. Could you begin again, please?
Okay. So
it's not a stable connection.
Yeah.
Victor?
Yeah. Again, so I think I'm having problem with my internet. So this has happened all the.
Okay, so please put the message in the chat, and let me see if there is another question in the meantime.
I have a question. Can I?
So can you hear me now? Because I'm having problem with the internet.
Okay, try again. Okay, let's try again.
Okay, so what I'm trying to do is I love to see different technology that can be applied to the sugar industry. The idea of using nanotechnology to do these things is great. And I was mentioned also that San Martino is trying now to develop different products and processes beside ethanol, sugar, and energy. So my question to you is, how can we use this concept in the sugarcane area? So I know that we can grow faster a sugarcane, but also we need to have the possibility to control bugs that always cut the productivity of the sugarcane area. So since Professor was mentioned about the sugar industry, yes, what else can we do using these
I think I can talk something about.
I think there's who would like to begin answering?
Yes, I can. I think I can start. I know my main topic of research is on bioprocess, but what I think is the sugar and ethanol mill can develop can be constituted as a biorefinery, and so generate different compounds that can be used for the to produce capsules or nanocapsules to be used. And on the other side, I think the sugar and ethanol mill use a product from agriculture, sugarcane. And then the agriculture, I think, should be one target for the development of the same concept in theranostic, I mean, release and targeting. These two concepts, I think, are quite important in theranostic, but it could be applied for applications in large scale. Agriculture in Brazil is a large scale application for the concept of theranostic to release substances as fertilizers or substance to control bugs or other plagues in agriculture.
Yeah, I believe that the concept we're dealing with, it have a very broad application, and agriculture is, of course, one of the main possibilities. We believe that it's possible, as Professor José Gregorio said, deliver fertilizers not only by conventional way, by the root, but we can think about by the leaves with no problem, I guess. And also, it's possible to deliver different kinds of bioactive molecules, including pheromones, including fungicides, bactericides, and so on. So I believe that if we have a chance to, think about the possibilities and go in depth on that, it's possible to think about many possibilities for improving the crops and the productivity.
Thank you. Professor Khalil would like to complete any other comment, Khalil? Sound. Yeah. Any comments?
Why not combine the nanoparticles for MRI with targets for the diseases in the fruit, for example, and check this? I don't know. This is one possibility to combine everything, and then, because if you think about the Embrapa and other centers about this this big net, you can use the MRI, for example, or radiation to eliminate pathogens or check the integrity of the fruit, for example. And why not combine this, not only painting in humans, but in agro? This can improve the quality of the fruits too.
I think that what I'll do is be kind of an ambassador, and if you agree, I'll pass Victor Hugo's email to you and your emails to Victor Hugo, so you can continue talking afterwards. So Martinho is, we like São Martinho very much, also not only because it's a large, brilliant, very well managed and advanced company in this area of sugar and cane, but also the current CEO is a former student of ours in the engineering school and the industrial engineering department. So we have some quote unquote vested interest that this connection will happen, and Victor is a wonderful middle person to make this happen. So I'll do that, and we are getting close to the end. Is there any other question for our speakers?
I have seen that there is no questions on the chat box, but I have a question. Can I?
Go ahead. Rafael is a doctoral student in management of innovation, so you have the due right to pose a question.
Okay, I'll try to be brief because we have another session that will start next. But my question is all the research that all the panelists have presented is really interesting, and this spring program is also interesting, as Professor Ari mentioned. to make spin the triple helix wheel in a positive way. My question has two aspects. The first, and you may have provided some examples, but how are at what stage all the research that have been shown in this panel is getting closer to the market? Is this becoming products or processes already? And the second question is about the training of the graduate students. What is how is this program
I think
organized for them, and are they being, for example, being employed in Spirent, for instance, or any other company after their graduate degree? Thank you.
Yeah, what I can see, speak is about our project now is in finish of the preclinical studies to start as soon as possible the clinical tests, thinking about only MRI contrast agents. But we know that is the moment to combine with the target agents. So this is the point now to get the market.
Yeah, this program, answering your question about in which stage we are just starting. Actually, this project was approved last year. And we are actually selecting, hiring the students for the fellowships, okay? But the concept we are using is trying to use the knowledge and technology that already have been developed in the different institutions, combine them in order to get a faster evolution of the technology, okay? So this, the sprint, the idea of a sprint is to join knowledge, join expertise of different professionals already working in their respective areas, but that when combined, we can have say an enhancement of the evolution process of that different kind of technologies. As you could see in the presentations, the materials that can be generated, the products that can be generated can meet different kind of applications. So the idea is exactly that, is try to exploit all the possibilities within the scope of this group that have a lot of researchers, professors from different institutions, including institutions like IPT, like Butantan, that is very close to the market. So I believe, and also we have this the communication part of the ideas to really try to how to say, to make this project known, and also to attract the interest from the community. So we believe that we have all the ingredients that, of the from the creative part, that is the idea, from the testing, from the dissemination, and also people that understand how to make the scale up, and also make the concept of the possible products that can come out from those technologies. So this is more or less what we have, I think, now. Professor José Gregorio, I think, can complement.
José, very brief because we are already being invited to leave the room. So please be very brief.
I will be very brief. I agree with Professor Koichi. We are starting, but I think we have a very good environment to training the students, because we have relationships with companies and we have different expertises. Many of these many of these products are in the market, but the challenge is develop new applications, really new applications that could be innovative. Okay.
Thank you. Professor Khalil, last words.
Well, one more time, thank you very much for invitation. And I know that this initiative is very important for us in all, especially when you're thinking people. Investing in people is best for great results.
Thank you so much, Professor Koichi Araki, Professor José Gregorio Gomes, and Professor Khalil Khaim, Rafael, for being our monitor. Aurora, I see you are already nervous to begin your session, which is on triple helix and government innovation in a time of pandemic. So be well. Thank you, everybody, and let's move on. Aurora, the floor is yours.
Thank you very much.
Thank you. Thank you. So the participants of next session, please, we will start in a few minutes. Thank you, Professor Plonsky.
It's the same room here, Aurora?
Yes, it
Okay,
is the same subject.
Okay, okay. I'll try to be at least part of it.
Perfect.
Aurora, Professor Aurora, I have made you the host of this session. So my turn in this as monitor of the room is over. If you have any, you are well. The administration of the session and the room is with you. Okay.
Okay. Thank you. Thank you, Rafael.
Oi, Regina, tudo bem? Ok, dá para falar. Escute, bom, primeiro, obrigado pelas informações. Deixa eu ver se eu entendi bem. Se eu entendi bem, você tem aquelas dimensões daquele pacote fechado que eu vi, e esse pacote pesa 3 quilos, é isso?
Sorry, Arina. So guys, we have a problem because some participants, they cannot access the Zoom.
Yes, I had actually the same problem. I had the same
Exactly,
problem.
me too. So I tried to send now a message to them. Some of them, I have the personal contact. So because by now it's only you and I, Irina, I think you are the first one, no?
Yes, I am the first one, but I see Carlos. Is he from our session?
No, Carlos, it's my PhD student.
Hi.
So Otávio is...
Se eu precisar levar a roupa e etc., eu tenho a impressão que 3 quilos...
But we have to make...
I tried to advise Professor Plonsky that you cannot...
Mm-hmm.
Just a second.
Eu estou achando difícil, sendo bem franco. Eu devo voltar em dezembro para Israel, e se Deus quiser, lá já tem voo direto. Espero, né? Então, em dezembro, a gente teria uma outra, quer dizer, se não for ninguém antes, em dezembro, eu teria uma outra chance para ser aí mesmo aí, mas é difícil. Normalmente eu vou. Tá. Tá bom, desculpa, mas fiz a conta direitinho aí e ficaria difícil mesmo. Tá bom. Obrigado. Você aparecer por aqui, espero que você ligue assim, a gente pode se ver aqui em Tel Aviv. Em Tel Aviv, Besseida. Tá bom, um beijo, Shabbat Shalom. Um beijo, obrigado. Tchau, obrigado. Tchau.
Aurora, may you unmute him as administrator, or you don't have
Yes,
administrator?
I forgot that I can do it.
I think you may,
Thank you for remembering me. I didn't realize, Irina. Why not just
because you have administrative
before? Yes,
right?
because I forgot that I'm administrator right now. Rafael, in the beginning I was just a participant, and now I have the power. So we have 3 of us. Maybe I just sent an email for again for you guys, the same address that I sent you a few days ago. And I think that for the time we should start. We have three authors now, so it's possible to start. We start with Irina, and then you can see with the other authors if you come or not, and then you can organize between Flavia and I. So Irina, the floor is yours, please.
Thank you very much. I will share the presentation. I hope it is seen. Yes, you see it?
Yes, great.
It's a little bit difficult title. My presentation will be about transformative research, which is now very much discussed actually in Western countries, but Russia not really tries to join the conversation, but the subject for Russia is very actual. What is transformative research? Actually, it's one of the terms for research which is somewhere in between fundamental and applied. And another term for it is HIBAR, highly integrative, basic and responsive, or user-inspired basic research. So there may be different terms. The idea is that when pandemic started, it was clear that many of fundamental results, especially in medicine, they did not allow to find fast solutions for global challenges. And the idea was that there should be more such type of research, which is from one hand fundamental in its nature, but at the same time, it is done with clear idea in mind that which problems or which challenges it has to address. So since it is combination, is rather difficult to match fundamental and applied. And in one of the studies of this HIBAR research, they show that you see that motivations, methods, partners, and timelines for applied and fundamental research are very different. So how to match them? The most difficult is motivations. In one thing, you try to solve problem. When you do basic research, you have desire for discovery. Also, you have different partners, you have different methods, and you have different timelines. Still, it's considered that it is manageable, and that exactly such combination creates so-called creative tension which brings to most advanced results. Also, there are studies showing that Nobel Prizes were awarded for such type of research in many cases. So, is this something new? No. This research actually was conducted in 20th century in large corporations which could afford to have big labs. For example, Bell Laboratories. They were doing transformative research, and as a result, there were many inventions made, such as radio astronomy, transistor, new effects in solid-state physics, and so on. And Nobel Prizes are awarded for such work. Current trend is sort of reanimation of this approach. It's very costly, so only really rich companies may afford this, like Google and Facebook. They reanimate this approach. In universities, transformative research is not very much developed. It's about 5% of total R&D. And in the United States, there is now a discussion that it has to be at least 20%, so that to receive better results, more useful results. Government agencies plan to boost transformative research by putting additional money for this type of activity. In the United States, it's Endless Frontier Act, which just passed Senate, and it gives additional money to National Science Foundation for creation of Technology Directorate, which will support these activities. Similar trend is in United Kingdom. In European Union, they are discussing more in frame of innovation strategy, support of this research. And finally, OECD this year issued a report where they analyzed different types of government activities to support such type of research. And their recommendation was that governments should more experiment with various approaches to foster this transformative research. Now turning to Russia, and Russia is especially actually important because if we look at the side of triple helix model, we still don't have even solid triple helix because state dominates in all terms. So we have very strong relations, state and science, or universities as part of science, state and business, but quite weak connections between science and business. And that means that in science sector, it's oriented on publications only, and business is oriented towards development. If we look at money distribution for R&D by sources in comparison with other countries, we will see that Russia and, as another example, Kazakhstan, they present picture opposite to developed countries. In Russia, government supports 66% of all R&D, and only 30% is business. In developed countries, right opposite. So from the financial point of view, we see that business is not supporting really R&D. As a result, what we see that if we look at output of R&D in terms of what results it's yielded, import and export technologies, Russia presence on prospective markets, we will see that results are very, very modest. Import always is larger than export, and income from export is many times lower than in the countries with which Russia likes to compare itself. Russia on prospective markets, you may see that it's really small portion, IT, electronics, pharmaceuticals, only pharmaceuticals 4%, even IT, in which Russia is considered to be God, it's only 0.6 according to IDS and Gartner market reviews. So what may be done? This is actually discussed not in terms of transformative research, but in terms of how to bring research and practical use closer together. And the idea is that we have to start from selecting or choosing those technological areas and industries where we are capable to start rely on our own R&D, not to be such dependent on imported technologies. And for that purpose, to do several steps, of course, it's more or less conceptual right now, but maybe it will happen in reality. The first step would be will be expansion of university level research, which is transformative and useful for later for business. Then in business sector, there should be creation of R&D sectors and based on technology companies which are capable and interested to develop technologies. And these centers will devote their activities to gradual going out of only purchase of foreign technologies towards development of own technologies. Of course, not all industries or technologies can be selected and extra funded for this purpose. So there should be some criteria how to define what is important first place for the country. And right now factors are maybe divided on external and internal capacity. External is that we see visible technological trends to which we have to build in, because if we don't do it, we again will be in catching up mode. Then if there are heavy impact, it should be an area where we see that there is possibility or risk to blocking import, or the price of import will become too high. Internal capacity includes that there should be research teams which have scientific potential in this area to develop something, because if we don't have scientific basis, we lost it, we will not be able to move from import to eventually to export. And potential demand of technology within the country and availability of companies that can develop this technology. Here, so that not to be very abstract, here are examples of 3 directions which are under consideration for support and further transformative research in the government. Now it's under discussion with experts and scientific community. And these are electric vehicles, new generation of telecom, and agri selection. And they meet all these criteria, but the worst situation is actually in agri selection, because this sector is very much relying on import. It's critical dependence, and if something happens, it will be disaster. And there are not so many scientifically advanced research, so that start immediately to improve the situation. In telecom and in like 5G, 6G, and in electric vehicles, situation is much better. And actually in our institute, we are working on electric vehicle subject right now, evaluating whether there will be demand on these vehicles among potential customers. Because Russia is strong in creating batteries, and batteries for electric vehicles, it's like 1/3 of the total price. So this is direction for technology development. This is generally all. I try to be fast. Thank you.
Aurora, you are muted.
Thank you, Flavia, and thank you, Marina. So if you have some questions to this paper, please take notes, and then in the end, you try to promote a kind of discussion, because right now we have this late to start the section. So the next paper is with you also, Irina?
No. It is mistaken in program because it's some other country.
The student online
everyone.
learning preference during the COVID.
Yeah, it's just a mistake.
Yes, for me it was very strange. Oh my gosh, Ireland has two different institution connections, one in Peru and another in Russia. It's unbelievable. So now we understood. So the next presenter, please.
Yeah, just give me a second.
Okay, so just to remind you, each presenter has 10 minutes to present the paper. Minutes, yeah. We decided to present all the papers during in the sequence, and then we'll be back for the question.
Okay, can you see my presentation right now?
Yes.
Oh, okay, thank you. Thank you, Aura. Thank you, Ariana, for your presentation and for your interesting research. I'm not going to take a lot of your time. Actually, we started a very basic research with my undergraduate student. You can see their name here: Carla, Victoria, Valeria, and Jacqueline. They were my undergraduate student in marketing department in Universidad in UDLAP in Mexico. As you can see, my name is Asghar Afshar Jahanshay. I don't know, something is wrong here. My name is Asghar Afshar Jahanshay. Right now, I'm a full-time professor in Centrum Católica, but last semester I had the opportunity to teach online classes for UDLAP in Mexico for research methodology class. And during this class, we try to design a research, a real research, and we try to know about the student online learning preferences during COVID-19 pandemic. As you know, this pandemic started almost 15 months ago in China, but spread quickly around of the world. And in Mexico also, Mexico is one of the country which hit heavily, we can say, by COVID-19, and we have a lot infected people, and unfortunately we have a lot dead people. In the beginning of the pandemic, I think in Latin America, I'm sure you know that almost in the March 2020, all the universities start going online, and they stop the campus teaching. And in this case, we have done a very simple research, and we try to know what is the student preferences for the online classes during the COVID-19 pandemic, and especially we target the student in UDLAB. And we had three simple research questions. We try to know what is the student preferences for online class teaching methods, for online class schedule, and for the online exam and assignment in this pandemic. And for finding an answer for these very simple questions, what the student prefer more. Okay, we start online classes. We have a different schedule. Some classes, we have some short classes, 15 minutes. Some classes are very long, or 150 minutes. Some classes are even longer, and some classes in the morning, afternoon, in the evening time, in the night time, and the break time between the two classes. How much we have to give the student the break time? How they are preferences for the exam, for the assignment. That was our idea. We try to know what they prefer more. Okay, we gave them we forced them to attend in online classes, and they have no other choices. But what they prefer in this classes in this time, what they prefer more. And we use an online survey. We collected data from 219 students, undergraduate students, and the survey was short, was around between 10 minutes survey, and we target just the undergraduate student from 5 schools of engineering, business, art, medical school, and social science. And the majority of our respondents coming from Mexican students, only almost 5% of our respondents are international students, and mainly they are female, and mostly they are Catholic, and you can see mostly they are coming from business and economy, but we have from science, social science, and art and engineering schools as well. And we asked them if they infected by COVID-19. Out of 219 students, 26 of students infected positively by COVID-19 in the last 15 months of the pandemic. But we asked them about their family. Almost 43% of them, at least one of their family member infected by COVID-19. And we asked them whether they perceive a high risk of infection in this time, because they are attending in the online classes. They are not forced to attend in the campus classes. But as you can see, the perceived risk of infection by COVID-19 is not too high among the students. And we asked them whether they are enjoying the online classes, online learning. Yeah, only 39% of them enjoying the online learning classes. And then we asked them if they are preferred to continue the online classes for the next semester. And the majority, as you can see, around 84% of them are not interested to have the online classes for the next semester. And if we ask them if they want to compare their online classes with the offline classes which they had before the pandemic, and the only 27% of them believe that they have an equal learning process in the online classes and in the offline classes. But the majority of them, 72% of them, believe that their learning process is a little bit worse than the comparing with the in-campus and face-to-face classes. And they have a high, as you can see, they have a high level of commitment to online learning, but the level of the satisfaction is not too high, is not too low as well. And the majority of them interested to have more than 15 minutes rest between 2 online classes. As you can see, is around 42%, and here is measuring the level of their happiness. As you can see, is above the average. The majority of them is the level of their current happiness is above the average. One of the interesting part of our research was about their mental health, how they are feeling, and we measured their depression and anxiety, and with the 4 well-established scale. And here is a result according to the mental health or according to depression and anxiety. Unfortunately, only 20% of them, 21% of them are feeling normal, and the 42% of the students they are having mild